Let's discuss question number 32 from test 2, and this is from machine design, basically from design of shafts. So for a power transmission shaft transmitting power at n rpm, so you have a shaft and you're applying torque, it's moving at speed n. Okay, so its speed is n rpm. You're applying torque and basically it's moving at a constant speed, so the net effective torque has to be 0. Okay, so it will be balanced, right? Okay, so now the power transmission shaft transmitting power at 10 rpm, its diameter is proportional to, okay, so the diameter is d. Okay, so now power is basically your torque into your angular speed, okay, t omega. Just like your, the work done is torque into angular displacement. The rate of work done is power. So torque into angular displacement by time, that is torque into omega. So this I can write T. Omega is again in terms of revolution. When omega is in radians per second, so what is given is revolutions per minute. So I can write 2 pi n by 60. So this is your power. Now how much maximum power I can transfer at a given rpm depends on how much is the maximum torque. Now maximum torque, because the shaft is always in torsional loading, so I can use the torsion equation to just determine how much maximum torque I can apply. So this is my torsion equation. T by J is tau by R, where J is about the shaft axis, J is your polar moment of inertia, so T by J is pi by 32, the diameter power 4. This is again from the definition of polar moment of inertia. When you apply for a circular cross section, it is pi by 32 d power 4. Tau is the stress, the shear stress developed, maximum shear stress at the periphery. R is T by 2. So from this, my T will be basically pi by 16 T cube into tau. So T max would be, the maximum torque I can supply will be d cube into tau max. Now this is a property of a material. Okay, this is a property. So maximum, say for steel, I can go tau max to be say 340 MPa. So based on that, this maximum torque is limited. Now so the power, now if I substitute this back here, I'll get 2 pi n by 60. Torque is pi by 16 d cube into tau. So maximum power I need to put I need to just stress it. So in order to get the maximum power, I need to just apply maximum torque, or the other way of saying is I need to stress it to the maximum limit, material limit. Okay, so that now this tau max will be a material constant. So all that if I substitute, so P, the everything else is constant, so it just basically depends on n and d cube and to some constant k. So d is basically the diameter of the shaft, which is p by n into some constant. Now this whole cube will go 1 by 3 there, so p by n 1 by 3 is what is the diameter proportional to. So the answer is A. Option is A. Thank you.